Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problems 1 to 5 of the Geometry Common Core Regents exam for August 2016. Alright, let's take a look at question 1. It says, in the diagram below, lines L, M, N, and P intersect line R. Question, which statement is true? So we have 4 lines cut by a transversal. So one thing you want to recall is that if parallel lines are cut by a transversal, then corresponding angles are congruent. Okay, it goes in both directions. So if parallel lines are cut by a transversal, then corresponding angles are congruent. Okay, now what we have to do in this problem is basically find the value of all the corresponding angles for all the lines that we have here. Okay, so the corresponding angles for all the lines are this angle right here, this angle, that angle, that angle. These 4 angles are corresponding angles. Okay, you could use those ones, or if you want, you could use these right here. Right here, those are corresponding angles. Okay, angles on the same side. We have the intersection of the transversal and the lines. So let me label the angles that we're going to be looking for. Okay, so let's call this angle 1, angle 2, and angle 3. Any pair of corresponding angles that are congruent automatically implies that the line that makes that corresponding angle with the transversal, the pair of those 2 lines are parallel. Alrighty, so let's go ahead and find the value of each angle. So angle 1 forms a linear pair with 78 degrees. So the measure of angle 1 plus 78 is equal to 180. Okay, according to the linear pair postulate. So we subtract 78 from both sides, and the measure of angle 1 is going to be carry 1 over 10 to 102 degrees. Okay, so angle 1 is 102. Now let's look for the measure of angle 2. So for angle 2, it's vertical angles with 122. So measure of angle 2 is equal to 122. Okay, let's put the reasons here. This one is a linear pair, and these 2 form vertical angles, and we know that vertical angles are congruent. Okay, so measure of angle 2 is 122 degrees. Angle 3 forms a linear pair with 68 degrees. So let's figure out what the measure of angle 3 is. Measure of angle 3 plus 68 degrees is equal to what? 180 degrees according to the linear pair postulate, just like number angle 1, just that the configuration is horizontal here as opposed to vertical in angle 1. So we have a linear pair here. Let's go ahead and figure out the value of angle 3. So subtract 68 from both sides, and that will give us a final result. Measure of angle 3 is equal to, if you do the math, you get 112 degrees. Okay, so do we have any pair of corresponding angles that are congruent? That is the question. So we can see that angle 3 and this angle right here are congruent. So if this corresponding angle that we have right here and this angle are congruent, these corresponding angles, what does that tell us? It tells us that line L is parallel to line P. Okay, so answer is option number 2. All right, let's go ahead and write down a real quick remark as to why we arrived at this conclusion. So when um, transversal since when transversal R cuts line P and L to um, corresponding angles that are congruent were formed, what does that tell us? Then lines L and P are parallel. Okay? Then lines L and P are parallel. Bottom line is, if you have two lines cut by a transversal and the corresponding angles formed are congruent, then those two lines cut by the transversal are parallel to one another. Alright, let's take a look at question 2. It says, which transformation will not always produce an image that will be congruent to the original figure? So whenever you're talking about congruency between an image and an original figure upon transformation, the first thing that should come to your mind is the term isometry. Okay? You have an isometry when the measures of the original figure are preserved after transformation. Okay? So in this particular problem, we're looking for what's not an isometry. Which one does not preserve the size? Does not always preserve the size. Okay? So first of all, what are your isometries? Do you remember the transformations that preserve size? First isometry you want to remember is translation. Okay, you're just shifting the object all around the place. You're not altering the size. Number 2 is reflection. When you flip an image about a reflection axis, you do not alter the sign. And then the last isometry is rotation. When you spin an object around the rotational point, you do not alter its size. Okay, so these are your 3 isometries. Which one is not an isometry? Not isometry. The transformation that's not an isometry you want to keep mind of is dilation. Okay? Think about your eyes when they dilate upon exposure to light. That basically means it's getting bigger, right? So dilation means that the size is altered. Okay? This one size stays the same, size is altered. So if you look at the options here, translation is an isometry. Rotation is an isometry. Reflection is, dilation is not. Okay? Whenever you have a dilation factor that's not 1, you have an alteration in the size between the image and the original figure. So the answer for question number 2 is option 2. Alright, let's take a look at question 3. It says, if an equilateral triangle is rotated continuously around one of its medians, which three-dimensional object is generated? Alright, let's start by sketching a equilateral triangle. It's not going to be perfect. So there goes your equilateral triangle right there. So let's draw one of the medians. Okay, I'm going to draw the median through the vertex on the top. Now, If I rotate this triangle about this axis right here of rotation, can you visualize what is going to happen? Now, when you rotate this triangle continuously about this axis right here, so you're spinning it around, what's going to happen? This point stays fixed, but this point right here rotates around, and this point right here rotates around. So this goes in that direction, around, and this goes in that direction. Okay, and then if you go continuously, they're gonna overlap each other and then go right back, just like that. All right. All right. So this dotted line right here that I just generated with the computer shows the path that these vertices at the base of the equilateral triangle will create. Okay. So if you take a look at this resultant shape, what on earth is this? This is a cone. Okay, so that's the result of rotating a triangle, an equilateral triangle, about one of its medians. All right, let's take a look at question 4. It says in the diagram below, measure of angle BDC is 100 degrees, measure of A is 50, and measure of DBC is 30 degrees. Which statement is true? So let's go ahead and populate the measures in the triangle with the given figures here. BDC is 100, measure of angle A is 50, measure of angle DBC is 30. Okay. Now, what do we know about triangle A, BC, and ABD? The classifications here are dependent on the measures of the angles. So if we figure out the measures of these angles, we will be able to solve the problem. Which angle can we solve for first? In triangle BDC. Now, why did I select triangle BDC? Because I have two angles, and using the triangle angle sum theorem, I could find the third angle. Okay, so in triangle BDC, the measure of angle DBC plus the measure of angle BDC plus the measure of angle C is equal to 180. Okay, measure of DBC is 30 degrees plus measure of angle BDC, that's on 100, it's equal plus plus the measure of angle C is equal to 180. Alright, the goal here is to find this angle so we'll know what type of triangle ABC is. Okay, so 300 plus 100 is 130 plus measure of angle C is 180. If you subtract 130 from both sides of the equation, that gives you the measure of angle C, which is 50 degrees. Okay, so this is going to be 50 degrees right here. So you notice that base angles are congruent for triangle ABC, which automatically means that triangle ABC is isosceles. Okay, so you want to note that the base angles of an isosceles triangle triangle are congruent. Okay. All right. So what we're going to do now is go over why the other options are incorrect. Okay, those are important things you want to know for the Regents exam. You don't know exactly what they're going to ask, so you need to know how to disprove the other options. Okay, so option 1 says ABD is obtuse. What on earth is an obtuse triangle? An obtuse triangle has an angle that's greater than 90 degrees. So if we want to determine that ABD is obtuse as a false statement, then none of these angles in this triangle should exceed 90 degrees. All right, team? So let's go ahead and find the angles. If this is 100 forming a linear pair here, this is going to be 80 degrees. That's less than 90. So if this is 80 and 50, this is going to be the supplement of these two because we know the sum of angles in a triangle is 180. So you just add these two, 130 minus 180. That's 50 degrees. None of these angles are greater than 90, so it is not obtuse. Measure of angle ABD is 80 degrees. ABD is 50, not 80, so that's incorrect. Angle ABD is scaling. What does scaling mean? Scaling basically means that no pair of angles are congruent, and no pair of sides are congruent. Okay? But take a look at angle ABD for a second. This angle and this angle are congruent, so triangle ABD is isosceles just as ABC is. So we can clearly see that option number 4 is wrong because this is not a scaling triangle. It is isosceles, just the same reason as number 2's ABC is isosceles, because you have two base angles that are congruent. All right, let's take a look at question number 5. It says, which point shown in the graph below is the image of point P after a counterclockwise rotation of 90 degrees? Now, when you rotate counterclockwise, you're going in the direction that's opposite of what the second hand on the clock goes, right? If you look at your watch face, you notice that it rotates like this. That's clockwise. Counter is going up and over, okay? So that's what counterclockwise rotation means. All right, so we are having a counterclockwise rotation here. Our focus is on point P, okay? So when we rotate counterclockwise, this axis right here ends up here, and this axis ends up there. So when we rotate counterclockwise, notice how close P is to this axis. So if we take this axis right here and rotate it over here, point P is going to fall perfectly on point A because it's, you see that proximity, that close distance that it has to this axis right here, the same distance is preserved here. So when you rotate it over there, point P is going to land on point A perfectly. Okay, let me do a short visualization here just to help you get the point. So I drew two graphs on top of each other. So I want you just to focus your attention on what's happening with point P as we rotate counterclockwise, okay? This might look a little bit messy, but just observe. So let's keep moving. All right, so when I rotate counterclockwise, 90 degrees rotation, okay? 90 degrees rotation, almost there. Bam. Which point does P fall on? P falls perfectly on point A. Okay? So that's what happens when you have a 90 degrees counterclockwise rotation. Okay, so now that we know what the answer is, which is option 1, let's talk about what kind of transformations would result in the other distractors that are presented in this problem. Okay? So how do you go from point P to B? To get to point B, from P you reflect across the x-axis. Okay, so reflecting point P across the x-axis will generate point B. Okay, How will you get point D? Question, how will you get point D? Do you notice that if you reflect point P across the y-axis, you have a mirror image that will take you to point D? So you reflect P across the y-axis. Now, how do you get to point C? This one you can get, well, this one involves a rotation, okay? There are two ways you can get to point C from P. First one is, method one is by rotating clockwise 90 degrees, okay? By a 90 degrees clockwise rotation of of P. That's one way, okay? Is there another way we can get to C other than a 90 degrees clockwise rotation? The answer is yes. What if we carry out a 270 degrees counterclockwise rotation? What's going to happen? If you do a 90 degrees counterclockwise rotation, it takes you right here. If you do another 90, which is a total of 180, it takes you somewhere here. And then if you do another 90, it takes you right here. So three 90 degrees counterclockwise rotation, a total of 270 degrees counterclockwise rotation will take you from point P all the way to point C. Okay, so you have a 270 degrees counter clockwise rotation is the same thing as a 90 degrees clockwise rotation. So another way to get to point C from P is by a 270 degrees counter clockwise rotation. Counterclockwise rotation of point P. Okay, so that's that. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Geometry Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this presentation or any concepts on the Regents exam, the math portion in general, just ask your questions in the comment section below and we'll be more than glad to support you. We update videos to our website on a consistent basis, so do subscribe to our channel for updates to other cool tutorials such as this. More clips can be found on Mathgotserved.com under test prep. Thanks again for watching and have a wonderful day.